Unit 3, Day 3, Perpendicular Bisector Theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. If a point is on the perpendicular bisector of a segment, then it is the same distance from here as to here. If xy is perpendicular to AB, then AY is congruent to AB. If perpendicular, this is P, this is Q, then YA is congruent to YB. In this case, the converse is also true. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. Of the segment. So, if AX is congruent to XB, then X is on the perpendicular bisector of the segment, and so is Y. If P, then Q. If XA is congruent to XB, then XY is perpendicular to AB. Sorry. If this is equal to that, then this is the perpendicular bisector. Well, how do we use this information? How is this helpful? Well, let's look at this problem. Find MN. Well, what do we know? Okay, this MP is congruent to PL, and we have a right angle. So we have a perpendicular bisector. Therefore, MN is congruent to NL, so MN must be equal to 2.6. How do we know? The perpendicular bisector theorem. Write it down, please. Okay, find the measure of BC. Well, AB is congruent to AC. We are given that information. And AD is perpendicular to BC. So, by the converse of the angle bisector theorem, BD is congruent to DC, so BD is equal to 12. BC is 12 plus 12, or 24, by the converse of the perpendicular bisector theorem. Finally, we have a problem where we have to find TU. Well, what do we know? We have a perpendicular bisector. If we have a perpendicular bisector, then what we know is this distance must be congruent to this distance. So how do we solve that? We set it up by saying 3x plus 9 is equal to 7x minus 17. Stop now, solve the problem, put in the answer, and we're done with this piece.